Hi students, let us now understand what is meant by Doppler effect. What is the statement of Doppler effect? First let us see. The apparent change in the frequency of a wave due to the relative motion between the source and the observer. This is the simple statement of Doppler effect. So many examples can be cited now. Now let us imagine we are standing on the railway platform. From far distance one train is nearing the railway station by whistling, continuous whistling. So we feel as if the train reaches towards us, the pitch or the frequency of the sound observed by the ears increases. We have a feeling. Whether it is real or apparent we don't know, but we feel as if the frequency of sound continuously increases. Suppose if the train continuously crosses without stopping and continuously whistling, it is receding away from us, it is going away from us. So at that time, how do we feel? As if the pitch or the frequency of sound decreases. But actually the whistling of the train has a constant frequency only. It is the observer who feels there is an increase in the pitch or frequency as the source is coming towards us or approaching us, and also feels as if there is a decrease in the pitch or frequency of sound as the train leaves us or recedes away from us. So this apparent change in the frequency of the wave, here sound wave, okay, and this is due to the relative motion. So the source of sound is the train and the listener is the observer. So they have a relative motion between them. Due to the relative motion only, there is a apparent change in the frequency of the wave. This effect only was called as what? Doppler effect. This Doppler effect can be observed in any kind of wave, whether transverse wave like light wave or all electromagnetic waves or sound waves which are longitudinal. In both the cases, the concept is true only. Now we are going to explain in the case of sound waves. So that sound can be listened, light cannot be listened, so light can be observed. So I can say the relative motion between the source and the observer or source and the listener. I told you observer means in the case of sound. Listener means in the case of sound. Observer means due to electromagnetic waves or light waves in general. Now let us take the case where the source and observer are at rest. So again let us stand on a railway platform. A train is waiting, okay, on the railway track, and now it is whistling without any movement. It is whistling continuously. So the same sound or the same frequency or pitch of the sound only we will listen. There is neither increase nor decrease in sound. Why? Because we are also at rest, the train is also at rest, and there is no relative motion between the source and the observer. So there should not be any change in the frequency, is it not? So let us assume that case first, the simplest case where the source and the observer both are at rest. So we can see, yes, the source is emitting some compressions and rarefactions. I have shown only the compressions, okay. So these red continuous circles are the compressions. So the distance between any two consecutive compressions is called as the wavelength lambda, and the number of waves emitted per second is called the frequency. So here there are some terms to be used. So throughout this Doppler effect derivations, what are all the various symbols we are going to use? Let lambda represent the wavelength. So this is either longitudinal wave or transverse wave, and F represents the actual frequency with which it is coming out of the source. So this is the actual frequency, and V is the velocity of wave, the velocity of the wave. So when sound is coming out of the whistle, that sound wave is traveling in the air, is it not? Wave, sound is traveling in the air with some speed, that is denoted by the symbol V. And next V, yes, this is velocity with which the source is moving. This is the symbol. The velocity of the source is represented by the symbol Vs. Since in this case source is at rest, I have written Vs is equal to 0 because it is at rest. And Vo represents the velocity of observer. Okay. So these three you have to be familiar. So V without any suffix is the velocity of the wave. Vs is the velocity of the source and Vo is the velocity of the observer. And in this case, observer is also at rest. Therefore, Vo is equal to 0 or V listener. Listener in the case of a sound, O in the case of light. In general, I have written V observer is equal to 0. So, in this case, what is going to happen? In 1 second, how many number of waves are emitted by the source? The number of waves emitted by the source is called its frequency. That is its actual frequency. Understand that? And in 1 second, how many number of waves are listened by the observer must be the same. So in this case, what is the relationship between lambda and the frequency? We have already studied the velocity of the wave. So must be equal to the distance traveled by the wave in a period. That is nothing but wavelength. So the distance traveled by the wave during its period, time period is wavelength. So divided by the period. So this can be written as V equal to lambda divided by T. So this implies V is equal to lambda into the reciprocal of the time period, or the velocity V is equal to lambda into frequency F. This equation we have studied already. Therefore, the frequency observed, the frequency observed is found to be F is equal to V by lambda, and this is also equal to F dash, that is equal to the apparent frequency. So, in this case, the apparent frequency is equal to the actual frequency. So, the apparent frequency is equal to the actual frequency. So, the symbol for the apparent frequency hereafter we are going to use F dash. F is the actual frequency. Therefore, in this case, F dash is equal to F, and that is equal to what? V by lambda. So, this you should be very much clear. Understand? Why the apparent frequency is now equal to the actual frequency? Why there is no change in frequency? Because there is no relative motion. Either the source should move or the observer should move, or both may also move either towards or opposite from each other. So, here in this case we have observed that both the listener as well as the source are at rest. So, in this case the apparent frequency is equal to the actual frequency. Now, this is considered to be the case 1. Next onwards we will take the different cases. Okay. I hope you must have understood this well. Fine.